All right, we're going to go ahead and get started. It looks like the number of influx has started to slow slightly. So welcome to today's webinar, OT Cybersecurity Best Practices for Digital Transformation in the Manufacturing Sector. Again, my name is Josh Carlson. I'm a Director of Business Development here at Dragos, and my role primarily focuses on identifying, establishing, and nurturing meaningful relationships, partnerships, strategic alliances with other organizations that seek to improve the overall value of Dragos offerings to our customers and ultimately strive towards our mission of safeguarding civilization. Before we jump into the presentation, I wanted to mention a couple of common items that we will get questions about. The session is being recorded, and a link to that recording will be sent out within a day or so following this webinar. So if you know someone who could not make it today, missed it, or whatever the situation may be, feel free to forward that link over to them, and we'd love for them to be able to listen in and participate in that. All of the lines have been muted just to avoid some distractions and things like that, but we do want you to interact with us. So at the bottom of your screen, you should see that Q&A button. Go ahead and click on that if you want to ask us a question, if you want to submit a comment, have feedback, a use case, a story, anything like that. We're always happy to see our participants joining in and interacting with us. And we're going to try to incorporate those, respond to them as appropriate towards the end of today's presentation. So with that, I'd like to take a quick minute to introduce the other panelists that are with me today. Dr. Michael Powell is a cybersecurity engineer at the National Cybersecurity Center of Excellence, or NCCoE, which is part of the National Institute of Standards and Technology, or NIST, based there in Rockville, Maryland. His research and focuses are on cybersecurity for the manufacturing sector, particularly how it impacts the industrial control systems that are supporting those environments. Also with me, John Hoyt is a lead cybersecurity engineer at the MITRE Corporation, where he supports the NCCoE at NIST. He specializes in cybersecurity for the manufacturing sector as well as other operating technologies used in different critical infrastructure environments. Both Dr. Powell and John, along with many other folks behind the scenes, have done an excellent job of spearheading the effort that went behind this presentation today. And we really appreciate their time and support, especially as it pertains to the manufacturing community. And last but certainly not least, joining us today is Dan Lopez, staff pre-sales engineer at AVEVA, where he works on the PI system technology, has done that for over a decade now, and has done an excellent job of helping us create some great content for you folks today. So with that, let's go ahead and jump into today's agenda. The overall goal of the presentation is to walk you through some of the details around exactly what NCCoE, Dragos, AVEVA, and others have been collaborating on and consequently creating for the community to utilize. The three key takeaways that we really hope to pass along today are: number one, there are solutions that are engineered for maintaining system and information integrity within manufacturing environments. This is not a shoehorn of IT solutions and things like that. These were specifically engineered, designed, and the guidance was created specific for manufacturing OT ICS environments. So we hope that that kind of comes across pretty strong today. Number two, the solutions are mapped to the NIST cybersecurity framework. So if you're following that as part of a risk management compliance type of strategy, we hope that this also helps you in that realm. And third, the scenarios and information that you're going to see today are based around real world examples. So to ensure that the solutions being provided are in fact, real world, that they will in fact protect manufacturing environments. So these are not like academic stuff that we just made up and are not likely to happen. These are, again, real world scenarios based on situations and public information that we found about. So with that being said, let's jump into a quick introduction of the three companies represented here today to let you know a little bit more about them, just in case you're not familiar with them. Just want to reiterate really quick that we're firmly believe, all three of us here and many others, but we firmly believe that it takes a village of solutions working together to adequately protect OT environments from the growing and evolving threats that organizations are facing today, and the ones that they're going to face into the future. So with that in mind, Dragos was founded in 2016 by some of the same people who created the ICS mission for the US government. We have grown to become the largest team of ICS security specialists in the industry on a global mission to safeguard civilization from those trying to disrupt that industrial infrastructure that we all depend on every day. We offer an effective technology platform that we'll talk a little bit about here in a minute that reduces OT risks by translating OT-specific threat intelligence and OT-specific services and the expertise that we get from those services into software that operates at the speed and scale at which OT defenders need. Here at Dragos, community is a core tenet of what we believe in as a company, and we realize that we can't do it alone. So we collaborated with industry-focused partners like AVEVA and NCCoE to strengthen our collaborative and collective defenses, build and spread knowledge to help defend a growing number of adversaries that are out there today. Dan, I'll hand it over to you.
For sure. And I'm excited to be here today representing AVEVA, where in a single nutshell, we make industrial software that makes the world better. And our users come to us with questions and concerns and issues across their entire organizations, everywhere from the critical operations side to engineering. And within the portfolio of technological solutions that we have, there is the PI system, industry-leading data infrastructure, been around for 4 decades. That was a key component to some of the scenarios that we're going to talk about today. And so we know folks sometimes have questions about, okay, how can I apply this to my particular site, my business, my industry? And that's one of the things that they thought, okay, let's get someone from the technical team here to answer those questions. So here to both do a little bit of presenting, but also really exciting, that live Q&A and discussion that we'll have at the end, here to help with any of that. And so with that, to introduce the third member of our group here, over to you, Dr. Powell.
Again, thank you all for having me. A little bit at the NCCoE, what we bring experts together from industry, government, and academia to address the real world needs of securing complex IT and OT systems and protecting the nation's critical infrastructure. We were formed in a partnership with the state of Maryland and the county. NCCoE assists industry with managing their cybersecurity risks by showing them how to use commercially off-the-shelf available products, such as Dragos and AVEVA, for this build that we just had, to improve their cybersecurity posture. Here at our facility in Rockville, Maryland, is home to more than 20 physical labs and over 35 active cybersecurity projects. Next slide, please. Thank you. And the NCCoE was established in 2012 as an applied cybersecurity division lab within NIST. In fact, we are part of the applied cybersecurity division under NIST Information Technology Laboratory. And a little bit what makes us unique is our work, is our close association with the industry and cybersecurity technology community. Through our work and relationships, we speed up the use of commercially available cybersecurity technologies and inspire innovation to address businesses and pressing cybersecurity challenges. And thank you all again for having me. And with that, I'm going to pass it over to John so we can discuss our project.
Thank you, Dr. Powell. So what we're talking about today is going to be some of the work that was done around the Cybersecurity Practice Guide 1810. So practice guides are taking the theory, kind of the cybersecurity framework, a lot of information. How do you actually take that cybersecurity framework and apply it into the real world? So in this case, we were looking at protection and detection of system and data integrity, right? So how do we see something bad happening? How do we stop it from happening in a manufacturing environment specifically? As several folks have mentioned, we're looking towards commercially available off-the-shelf technologies that can be applied to these things. So in this practice guide, we actually had a total of 11 different scenarios. We've narrowed that down to 4 scenarios to talk about today. These are ones that focus specifically on data historians and behavioral anomaly detection. The 11 scenarios that we demonstrated in the entire practice guide. We looked across the industry, we looked at existing incidents, and we also worked with our community of interest to try and identify areas that were of particular interest to manufacturers. So we established these based on all of that feedback, right? So just at a high level, right, we're going to hit unauthorized device-to-device communications, manipulation of sensor data, and then unauthorized modification of PLC logic and PLC firmware or device firmware, right? These are things that could happen from an adversary, but these also could happen from an insider, whether malicious or not malicious. We need to make sure that we're maintaining that system integrity so that we can have the resilience to continue production. These 4 scenarios were executed in an environment. We worked in partnership with the NIST and their engineering lab to work with their representative manufacturing environment. In their representative manufacturing environment, they have at the higher levels, they have common components that you might find in sort of the business operations, but tied to the manufacturing sides. So this could be anything from an Active Directory server to legacy backups of the Pi Historian or other enterprise level manufacturing applications. They also have a representative process control environment you can see on the left side, and on the right side, a representative collaborative robotic system or kind of a discrete manufacturing. We're going to mostly focus on the discrete manufacturing today. And so the important thing here is that there's a PLC that's coordinating the operations of a couple of specific robots, and then some machining stations that then the robots interact with. For more information of this, feel free to see the NIST IR 8089, and there's lots of detailed information about this. All right, we'll go ahead and head on over to Josh, who's going to talk a little bit about the Dragos platform and how it's used.
Awesome, thanks, John. And I just wanted to take a brief moment to introduce you to the Dragos platform technology that was leveraged throughout this exercise. Basically, it integrates the expertise from our world-class practitioners in OT cybersecurity services, as well as our OT-specific threat intelligence. The platform provides organizations with a 360-degree view of the OT assets, the network traffic, vulnerabilities. We fund a very large intelligence group to get this information that identifies and tracks threat groups, conducts in-depth research on their techniques. We analyze different types of vulnerabilities, often correcting information that might show up in a CVE, providing alternative mitigation advice that supports that threat detection methodology, ultimately to help protect you against the sophisticated adversaries that are out there today. So that's one kind of data feed set. The next data feed set comes from our, again, expert OT services group. These are the folks that are conducting the different types of customer architecture reviews. They do penetration tests, conduct threat assessments and threat hunts. They're the key, some of the key incident responders that are going out there today. When an organization has an incident, they call on us, we go out there, we help figure out what's going on in those industrial environments. And then we take that expertise, we take that knowledge, we take that experience, and we codify that into our threat detections, into our response playbooks. And then the playbooks themselves include in-depth forensics, OT-specific guidance to aid the incident response teams and to help them resolve the issues before they become a significant threat. OT Watch is a managed service where our OT experts help manage vulnerabilities, threat hunts, incident triage, things like that. And the Neighborhood Keeper provides community-wide threat visibility across the platform in an anonymous way that, again, helps support that broader capability for the OT community to leverage that information. So if something's happening to one entity, they can figure out, hey, are our defenses, are we seeing that same type of activity inside of our environment? So that's just a quick overview of the Dragos platform in case you were not familiar with it. Now I'd like to hand it over to Dan, let him tell you a little bit more about the historian.
For sure. And part of this that made this really exciting is we wanted to try to adopt an approach that would resonate with you all. And especially looking at the hundreds of participants that we have in the chat right now, We know that at the end of the day, the physical pieces of equipment, the pumps, the critical operation systems are going to come from all sorts of different makes and models and vendors, different physical devices out there. And so key to being able to apply the Dragos solution at each of these unique sites, regardless of all that, meant establishing a foundation of a data infrastructure. That meant when it came to doing analytics and calculations and setting up alerts and doing this kind of analysis, we had all of the key components that we needed running to be able to do everything from collecting that data in real time, hundreds of thousands of events per second, to storing it and allowing multiple different queries, feeding that data to exactly the folks in the application who could provide insight on it. And then on the delivery side, of course, which is what you're going to see here, folks talk about how that information can be served up to users. And so it is the Pi server, the Pi system as a whole, that supply that data infrastructure under the hood. Now, on the next slide, we want to talk about what was the actual approach that we took using Pi technology. So let's take a look at the next slide where we lay out how Pi specifically can help here. And the exciting thing is this general approach of how the Pi system turns data into information is something that's usually already being done at engineering and critical operations sites. And so here we're taking that same tried and true technology, it's been around for 4 decades, been battle tested and field hardened, and applying it to do these same kind of steps, but now for these particular cybersecurity use cases, where we're using that data archive to serve as that single repository for all individual queries for data, where we're saying, okay, this data needs to come from physical pieces of equipment that have context, that have interesting metadata that we're going to use in our alerts. Let's store that in the asset framework. And then lastly, of course, when it comes to making this actionable, which you'll hear about in some of the scenarios later, where we're doing things like using asset analytics and event frames to create triggers based on that data and notifications, ultimately to serve it up to the folks into the systems that can act on it. This general workflow, again, which folks are already doing and which in a lot of cases already exists, which is great because that's a key first step, was simply retargeted at a new use case for some really, really exciting results. And so to talk about what those results are and okay, how can we apply all this with this infrastructure under the hood? What specifically were some of the scenarios that we targeted and what were the innards of those? So that's what we want to do next. Hand it back over to Josh to get into what scenario 1 was, where we used all this in practice. So go ahead.
Awesome. Thanks, Dan. Appreciate that. So hopefully now you've got kind of a good synopsis of what the goal of the project was as a whole. We've talked a little bit about what some of the technology was and the end results that we were looking for. So now we're going to take a bit more of a deep dive into the actual scenarios. So this first scenario, detect unauthorized device-to-device communication. Really the objective was to say, hey, we've got a device that's here that was not doing this type of communication between these 2 devices before. So that was our test scenario. What happens when we change a configuration or do something like that and create a new set of communications? Do the solutions that we've got deployed in the environment actually detect that? And what would we do about it? So let's take a look at the network topology that John talked about. And again, one thing I'd like to just kind of reiterate really quick is these scenarios, all 4 of them that we're going to be talking about today, could be the result of an insider doing their job, but just not following the proper procedures and protocols and things like that that are supposed to be when it comes time to make changes in the environment. They could be from a malicious insider, or it could be from an outsider, right? Somebody trying to do something to damage or corrupt the environment. So don't think of everything that we're talking about today just in the context of, yeah, but they couldn't get in remotely, or they couldn't do this, or they couldn't do that. Think about, all of these scenarios being, how do I address this from an authorized person and malicious insider, and then a malicious outsider potentially as well. So taking a look at this scenario, right? This is your typical cybersecurity journey I like to think about because it's one of the first critical controls for ICS OT networks, right? Effectively, what you do is you start by passively gathering an asset inventory, identifying key OT assets in the environment. You're baselining their communications. How are they talking to one another? What are those models that they're using? What are the protocols that they're using? And then effectively, hopefully, you're continuously monitoring that traffic for changes within that OT environment. The actual technical situation that I'd like to describe that's happening here for those folks who are interested in that is we've got a couple of virtual PLCs. Those virtual PLCs were manipulated to begin communicating with each other in ways that they had not done during that initial kind of discovery, passive listening, learning, etc. And this would be representative of either a potential misconfiguration after an update. Maybe you make an update to the firmware or something like that, and all of a sudden there's new communication. Maybe it's expected, maybe it's not. It could also be representative of an adversary beginning to execute some malicious activity within the environment. We call that lateral movement, or pivoting is another word that you can use to kind of describe this communication that's happening. So threat detection in this case is about capturing and identifying those subtle behaviors, right? Nothing went boom, nothing stopped operating. It was just a new set of communications that were happening. This could be, again, an early warning indicator that something is changing within the environment. The early detection capability obviously is key in this situation because it allows the OT defenders to start the incident investigation process. Quickly look at the issue, understand, via a playbook, what do I do, right? And help efficiently guide me to what is the root cause of that change? Why did this happen? Document that forensics data within that playbook. And ultimately, the goal of the OT defender is to get the system back into a known, good, trusted, safe operating state. I used a lot of adjectives there, right? But it's a known good. We want to trust the configuration from a system and integrity perspective. And we, more importantly, or probably the most important thing that we often talk about in the OT world is safe, a safe operating environment. Right now, again, it's important that we don't rely simply on this anomaly engine or this, unauthorized detection as our sole way to detect changes and things in the environment, because more than likely this is going to happen on the regular basis. You're going to have a lot of alarms from for OT defenders to have to deal with, which could also result in missing some sophisticated adversaries. But it is a good core component to understand. So with that, I'm going to pass it over to Dan and let him talk through scenario 2 for us.
For sure. Thanks. And I think that sets scenario 2 up really nicely because, again, there were a lot of other scenarios that we applied this to, and we wanted to boil this down to 4. And some of this is inspired by having some great expertise of folks review this and understand how this could be applied in a larger case. And just very often, one of the questions that comes up is folks saying, okay, we've talked about unauthorized device-to-device communications and just the transport of information back and forth. But wait a second, can we even extend this one step further into the message that are actually being conveyed? Like what is actually in that data? And that's where, again, leveraging all these different components, the entire collection of expertise meant that we could do this very, very well. So in this case, the simple scenario is a scenario in the manufacturing system is sending atypical values to the rest of the infrastructure. It's getting stored in the historian, calculations, displays, etc. And so what we wanted to do is demonstrate that, yes, we could actually detect that if values start coming in that aren't expected, that are outside of limits, or if, say, they're coming from a piece of equipment that simply should normally not be sending values in this range or in this set of digital states, that we're able to capture that and perform actions on it, deliver the information to folks 24/7, 365, regardless of what shift is going on while folks are sleeping. And that's what we want to show on the results, like that we could actually detect that atypical data, and in terms of being actionable, create something called an event frame. And now let's talk about like what exactly that looked. And I think the next slide illustrates that really well. So focusing in on this middle piece of the architecture, we had the case where we've got a PLC. It's normally sending valid process values that people use for their reports, their calculations, regulatory compliance, all sorts of critical use cases. And now what happened in this case is that normally sends values within a certain set of enumerated states consistently, and people expect this. But now in this case, it starts sending new values that are outside the normal range, like outside the normal array bounds. And again, this could be due, exactly as you heard in the previous scenario, to all sorts of use cases or all sorts of causes. Maybe this is someone simply accidentally messing with a program file, or maybe this is something more malicious. Someone is actually deliberately tampering with this data, knowing that since people are basing decisions on these values, it can have larger impacts. But the important thing here is we were both able to set up those event frame triggers to detect by doing a simple test that, yes, these values are outside the normal range, that they're not expected coming from this device. But through setting that up, also adopt a templatized approach. Because if someone's looking at this and says, okay, yes, I get that. Maybe this could be of interest to us, but we've got multiple pieces of equipment, multiple different key tags, key PLC values. Is this something that's extensible? And yes, that was another key part of this particular scenario. Not just verifying that, yes, we could capture those, but also that this was a scalable approach, because there are a lot of different sources out there. And we wanted to make sure that scenario 2 could extend beyond simply looking at a single case. But I don't want to steal any excitement from the other scenarios out there, because again, just like with moving from 1 to 2, we wanted to show that we can address on this architecture diagram. And so on the third one, I can hand it back to Josh. And now we're going to say, okay, if we're talking about what's going back and forth between the devices, unauthorized communication, now we're going into the messages and figuring out, okay, what's in those messages? Well, let's hop even further upstream. What if something anomalous goes on actually with the PLCs? And I'll hand it back to you, Josh, for this piece.
Awesome. Thanks, Dan. And I think you've really set the stage up for the audience here now to take a really good hard look at saying, okay, so, well, how in the world did those messages get modified in the first place, right? How was somebody able to get in? And so that was the third scenario that we've set up here, is the ability to go in and say, hey, I've got a situation where somebody has gone in and modified the PLC logic, right? As Dan was just talking about. So the authorized user, right? Whether that's, and I'm going to use air quotes there, right? An authorized user remotely connects to the manufacturing environment, modifies, downloads the PLC or the logic file, sorry, back to the PLC. Can we detect that? Can we alert on that activity to help avoid or potentially reverse those things? And so again, taking a quick look at the architecture slide, just to keep everybody on the same page. So here we've got that authorized user to be on the system, right? It's somebody who, it's a known set of trusted credentials. They're performing an unapproved or unauthorized modification, though, of the logic that's actually going. So it's not a new device. It's not somebody getting in there and making, crazy, hacker style stuff. It's, hey, this is an engineering workstation. It's supposed to be there. It's communication that's happening between the engineering workstation and the PLC. That's supposed to happen. But what's not supposed to happen is this unapproved modification. And so the idea behind this scenario is that system integrity is key, right? It was working perfectly fine an hour ago. What has happened now? And how do we go back and figure out what that root cause is? So in order to maintain that safe and reliable operation. Change control obviously is another kind of phrase that we can use. It's an imperative component of maintaining that system integrity. So in this case, we wanted to be able to say, hey, how can we modify or how can we detect these types of changes? And so passively over the wire, we were able to see, hey, that's an unauthorized change. Go in, take a look at the environment, figure out, oh, this is exactly the bit that they were flipping, from one, setting to the next. And that's where changes begin to kind of, waterfall down that. And so organizations must have a certain level of trust within their staff. Totally get that. Again, that's why we kind of took this authorized user approach. But are they following the documented processes and procedures to make changes within the environment, right? So that was one of the things that we thought. And again, really, really cool opportunity for us to say where, how quickly in the modification, in the unauthorized detection process could we find something happening and get in touch with it. On the next slide, it actually goes to a little bit of the information around how we would detect it and what it would look like. So this change detection capability, again, is key for the OT defenders to trust, but verify every person and system within that environment. So at this point, they can follow the processes and procedures outlined in their incident response plan. Perhaps it was, again, a legitimate change in the user, and we just need to have some user training take place, along with some documentation now, because there's been a change in the known trusted state configuration. Perhaps it's a situation, though, where user credentials may have been compromised. Maybe they were default credentials that the system integrator just left in place and didn't go in and make those modifications. That's a real world scenario that we've seen, especially over the weekend. There was a big password dump on Twitter. Unfortunately, a bunch of default credentials for OT equipment. And we hate to see things like that. So But again, the goal is to help the OT defenders efficiently find the root cause, figure out what happened, document that forensics data, and get the system back to a known, good, trusted operating state. All right, last one, scenario 4. Thank you so much for hanging with us thus far. Hopefully this has been telling a great story for you guys and you've been able to follow along. So in this scenario, what we wanted to do was we wanted to detect unauthorized firmware modification. And this is one of the scenarios where we blended together capabilities from the AVEVA solution as well as the Dragos solution. Again, kind of telling and completing the story of it takes a village for these environments to adequately be protected. So we've got an authorized user, again, somebody who's supposed to be there, performing a change on the firmware, right? Can we detect that? And so what they do is they have local access to the PLC. And what was unique, if we move to the next thing, just to kind of keep everybody in line with the idea of where this sits within the network. So the scenario describes how AVEVA and Dragos work together. Talked about that. What we want to do is we want to be able to identify and detect an authorized firmware change. So here we have unauthorized firmware modifications, but you can look at this from a compliance perspective, right? Hey, maybe I need to have all of my firmware on a specific version, right? So my compliance and my risk management folks are like, whoa, wait, that would be really interesting for us to be able to do that. Again, but it falls into that trust but verify. I trust my maintenance team to do the things that we need them to do with this new firmware, but have they updated all the PLCs? Has somebody accidentally loaded at some time in the future, perhaps, an unauthorized version or that deprecated version that is vulnerable to whatever, right? So in the AVEVA solution, what was really cool here is we created a tag to capture and monitor the firmware version of the Beckhoff PLCs that were used. Now, these particular Beckhoff PLCs are not updated through an Ethernet connection. You might have read that in the description on the previous slide. But they're actually updated through an SD card. So what that meant was there's no way for the Dragos platform, because we're passively monitoring things through the network, right, and the Ethernet interfaces, we couldn't passively detect that firmware change because it didn't happen over the wire. So in this case, we had to collaborate between the process technology like AVEVA and cyber technology like Dragos. So OT defenders now can benefit from extending that level of visibility from those two solutions, integrating that data set together, right? And again, wouldn't be possible with a single solution. So whether you're looking at this scenario from an unauthorized change or a compliance or risk management perspective, having the ability to leverage multiple types of detection, review them through that singular cybersecurity solution, help reduce the amount of time that your team is going to spend on that initial triage, incident reporting and things like that. So again, ensuring that systems continue to operate in those trusted, known, good, safe state. So hopefully that was clear. And with that, I'm going to turn it back over to John and let him summarize us out.
Thanks, Josh. So this is one of the most interesting things I saw coming out of our practice guide, right? Is the use of existing or legacy tech. I don't even shouldn't even say legacy technologies, right? Technologies that are existing in an environment. You know, manufacturers already have process data solutions in their environment. How can that data be used to go, you know, to help secure that environment and then integrate with security products? So this is one of the most interesting things I've seen coming out of this practice guide, and I'm really happy that we've been able to talk about it today. So if you get a chance, please visit our website, you know, nccoe.nist.gov. You can, you know, write in the whole URL, or you can just browse around. Download the full guide so you can get the full 11 scenarios, not just the 4 that we talked about. You can also see in that guide the mapping of the scenarios as well as the technologies to the NIST cybersecurity framework. So you can see how this can apply to help improve your cybersecurity posture. And then, of course, you know, this is a demonstration of commercially available technologies that can help secure the system and information integrity in the manufacturing environment. So that's it in a nutshell. All right, moving on to the next steps. All right, so at the NCCoE, the next thing we're working on, right? So 1810, what we just talked about is protecting and detecting adversary behavior or system integrity compromises. Well, we hope that those are successful. We hope that the protection is successful, but we know that it's never going to be 100%. So we need to prepare for the next step. So the next step that we're looking at NCCoE is how do you respond and recover when there is a cyber attack. So again, head to our website, nccoe.nist.gov, and take a look at our proposal for the next guide around response and recovery. So going over to Dan, talk about what else is going on at AVEVA.
For sure. And we mentioned earlier that one of the exciting things about being AVEVA and one of the exciting things about being an engineer there is that when people come up to us with, again, their critical operations challenges, yes, there are solutions and tools that can address those. And here's a case where we can leverage that data infrastructure, since that PI system that these scenarios are built on is already so common. This is just yet another use case where folks can say, awesome, we can take advantage of the fact that we already have this up and running, that we already have established connections out to our PLCs and our SCADA systems, and we can just simply retarget this at this use case that's just been bugging us forever. So with that, we've already seen some great questions, and I do want to just re-ask folks that while we've got this amazing group of panelists who can address all aspects of these scenarios, everything from the ground level where we are in AVEVA all the way to the highest level analytics, that you please direct your questions to us. Because in a nutshell, we're looking forward to talking to you all about how you could apply some of these amazing technologies at your own businesses. And then finally, to hand it over back to Dragos.
Awesome. Thanks, Dan. And so, yeah, I just wanted to highlight one thing, another collaboration effort Dragos and AVEVA have done, if you missed it, was around this whole consequence-driven approach using the bow tie risk model. This webinar and white paper examines the benefits using bow tie risk analysis, which was traditionally meant for safety, but we actually put it in the context of cybersecurity. Another resource I'd like to point out, a couple of questions have been asked this. I was just taking a quick look through around 5 critical controls for world-class OT cybersecurity. So this is kind of your best practices OT cybersecurity, because that continues to be a topic of top priority for boardrooms all the way down to the manufacturing floor, right? CISOs and their teams have to implement proven strategies, technologies to protect their business while overcoming some communication challenges. There's oftentimes a cultural gap between the IT folks and the folks doing the OT manufacturing floor. And sometimes perhaps it's just uncertainty about how to move forward. And so this guide here with the 5 critical controls can help do that. So again, with that, I'd like to thank everyone for taking the time out of your day. Really appreciate it. We know that it's valuable, and we certainly appreciate you spending some time with us. We're going to go ahead and start opening it up to questions. A very, very good question right at the beginning. I'd like to direct Dan right to you. Was the event frame triggers? Can we place limits on these? And I think this really goes to kind of the question of, what's required, right? What was some of the technology that was required to make this happen? Do we have to have, certain licenses or things like that? But, and then specifically diving into the event frames a little bit themselves, can we place some limits on those so that we're not getting too crazy with the event frames and things like that? A good question for you.
Yeah, totally. And there was even a second one about event frames. I'd like to address both of yours because, like, both of you clearly you had the same idea. So straight answer in a nutshell is, so those triggers are completely customizable, because it's like, yes, you might have different response times, different types of equipment, your data might look different. But one of the really interesting things that someone brought up was, is this event data accessible to plant personnel, or is this a managed system? And that really hits this on the head. That's why when figuring out, okay, we needed to collect data, store it, deliver it, why we didn't want to come up with just a bunch of click together point solutions. We say, no, let's start with the foundation of a data infrastructure, because you are exactly right. Yes, through the rest of the platform, you can see this from a cybersecurity angle, but there's a comment, hey, this could be useful for CBM, condition-based maintenance. Yes, those exact same event frames, that exact same tag-based data, if someone who's just right on the plant floor wants to see those same events, they can use those too. So you're having that single version of the truth that's also serving the cybersecurity context. Yep, also directly benefiting those folks out on the floor, and getting into those event frame triggers. if there's someone who says, oh, you know what? I think to make sure that we don't capture false positives, gosh, I'd like to change these trigger thresholds on a sliding scale, maybe by the day of the week, hour of the day, what recipe is going down the line, what SKU we're manufacturing. Yep, that trigger is a trigger that based on real time, like time series data, and time series data is exactly what that Pi system infrastructure is perfect at handling. So yes, we practically see that a lot of those triggers can feature a bunch of different values all within expressions to make sure that we really are capturing the right events. So how those event frame triggers are configured and everything, again, like this is stuff I do day in and day out. So happy to talk about this at way more detail, but there's a couple other good questions that I want to make sure we also answer. So feel free to reach back out afterwards if you want to get into more depth there.
Awesome. Thanks, Dan. I think that was really great. And there's a couple other questions that were focused on, what tools are you guys using to capture this device-device communication? Does Dragos have an on-prem situation? Kind of what is required to make this happen? And so I'll take that one just to address it from a Dragos platform perspective. So you have a physical server. It could also be a virtual server or what we call a sensor that's actually inline using a span port or a network tap. A couple of different configuration options that you could use there. And what we were then doing is we were just passively listening to all the communication that was happening across the different devices. That sensor actually picks up that new device-to-device communication and sends it up to what's called the Dragos site store, a management console of sorts, if you will. It's where all the reporting and things like that. So a lot of the analytics are done down at the sensor level to minimize the amount of traffic and information that goes up. And then we have that event frame collaboration and connection that Dan was just talking about. And that's actually a free integration module that we just include. So if you've already got a Pi historian that you're using today, you just go into the Dragos site store and you connect up and you link the assets together. So you've got physical, Dragos site store, physical Dragos sensor. You can also do virtual if that's more of your manufacturing floor these days. And then you can, leverage those connection points between your Pi server and the Dragos site store. So great question. Thank you so much for that.
I'll go ahead and throw in the part that I forgot to add about the practice guide. So the practice guide comes in 3 volumes. Volume A is the executive summary. If you got executives, have them read it. If you're an engineer, move on. Volumes B and C. So volume B is the details of the scenarios. So that talks through, what the assumptions were going into the scenarios and things like that. Volume C is that detailed implementation of this in the representative environment. So it talks about how the different pieces were integrated into not just the environment, but also integrated together for AVEVA and Dragos. Back to you, Josh.
Awesome. Thank you so much. Got a couple questions around scenario 4. So basically, can a change of the hardware, for example, like, if you power down the machine and you put an entirely new PLC there, or if I don't have any type of connection coming from that PLC, how could we leverage that and mean that there's no communication? So a couple of different questions there. The first part of that question, can I detect a change in the physical hardware itself? And the answer there is going to be, it depends, right? So it depends on how the PLC operates. In this case, the Beckhoff PLCs were fairly straightforward. And so we could easily detect changes in their architecture. I've dealt with some other ones, the Allen Bradleys and things like that, some of the Schneider equipment where you've got multiple components that plug into a backplane. And so there's ways to get that information from the device and tell if there's been some changes to the physical hardware itself through, different system calls. Maybe it's a MAC address or something like that, if it's part of the Ethernet communications. So different things like that. That you could definitely do some change detection on. And I think, Dan, there was some event frame stuff that we could set up on that. You want to talk about that for a second?
Yeah, totally. And actually, I think, again, blending 2 questions here where someone said, oh, how do you do this with hundreds of sensors? So there are cases we discussed in looking at different real world applications of this, where some folks say, you know what, we're wizards at PowerShell or scripting. We're just going to do everything like with a script. Others folks say, you know what, we're going to get in there by hand and tailor each of these. But getting into how you can address like scenario 4, kind of doing both of these, Well, some of the data collection technology, again, in that AVEVA Pi system data infrastructure at the bottom level, some of those technologies, again, really depending on the sophistication and the type of the controller out there, can actually do auto discovery. And not just within a single node, but across like a full address span. So I was literally working with a micro modular data center where it was a single piece of data collection software that was individually pulling in the field replaceable unit numbers of dozens, I think scaling up to just the full micro modular data center, of field replaceable unit numbers through the out-of-band board management controller. So actually going around the underlying application that was running, looking directly at the physical hardware. So it was not just getting, okay, this is the stamped on baked in serial number of this board, but doing this across the entire rack and across every single row of racks. So I guess addressing two of these questions, how can you do this at scale with like hundreds of sensors? Some of the data collection, the data collection technology does support like auto discovery and like mass collection of multiple different sources. But even within it, folks, especially who are using like Pi systems right now, might say, yes, while we're looking at pressures, temperatures, other process values, storing those kind of strings or enumerated states for firmware values or version numbers, just yet another Pi tag that Pi is happy to accept. So again, like I know introducing a new story there, and happy to get into that in more detail too. But again, we've got a good number of questions, so I want to make sure I save time for everyone else too.
Awesome. Thanks so much, guys. Really appreciate that additional insight there. One of the things that that was kind of asked right up at the beginning, and I think it would kind of layer it in with a couple of different thoughts. Any comments on discovery, reconciliation, and how it impacts security monitoring and incident response? So I think the question is getting to, look, and there was another one that was kind of like, Dan, you just talked about it a little bit. How do you do this at scale? How do you do this when there's thousands and thousands of devices and every device is talking to one another and things like that? I think that the best way that I can answer this question is really just to say it's the magic of the sensor. It's the amount of things that we're doing inside of that network infrastructure, monitoring those devices, not creating any additional load, not doing any polling or querying of the devices, letting them kind of do their operations on the manufacturing floor. And then we're just passively monitoring, recording, creating those snapshots and those baselines of communication and saying, when something like this changes, we need to go in and do it. And one of the things I think, again, where this question kind of starts out is the discovery and then the reconciliation. In a previous life, I worked for an OEM manufacturer, and one of the things that I challenged a lot of our customers with was, hey, listen, we're going to provide you with some documentation, but I highly encourage you to trust us, but then verify what we've given you. And so have something that would go out and would do a discovery and would give you the ability to reconcile how many devices, how many things are communicating across that network. And again, with that Pi integration that we've got going today, you can actually map the different assets and tags that you have within your infrastructure today, the things you know about, and compare them against what you see in the Dragos platform and say, hey, wait a second, there's some other devices, there's some other things here that we're either not monitoring with our Pi server, we don't have any tags set up for them. And so maybe that's something we need to look at. Was it left there accidentally during the last turnaround? Somebody forgot to take away, kind of a temporary access or a temporary device communication module, whatever. Lots of those types of things that, again, not a hacker breaking in, right? But somebody else just accidentally forgetting to do something with that. Dan, any thoughts on that?
Yeah, part of it also gets into when we keep mentioning the idea of whether it's a hacker or someone maliciously or someone, I guess, negligently making these kind of actions. I was reading through the questions, and I think this takes it in a slightly other direction that I want to get here. Is part of the beauty of the system is helping to inform folks of, okay, if we happen to catch a few cases that are maybe not someone taking malicious action, but cases where folks simply need new training or need to refine their procedures, well, how can we, again, leverage the existing infrastructure that we have, like getting back to those components like the asset framework, those templates, those instructions. We're saying, you know what? We're going to change the way these displays are set up, change the metadata, the information that's presented to users, ultimately to help reduce the amount of times that someone is getting in this scenario in the first place. there's a whole separate topic about how some of these results that we derive can be rolled back down into taking a post-mortem and figuring out, okay, how can we help prevent these from happening? And I know this is kind of taking the answer in a slightly different direction, but this is something that I know some folks who look at this and say, okay, let's make this even more actionable. Like, how can we use this to change our business processes? And an awful lot that can definitely be done there. So I guess, sorry, I wanted to chime in at least with that part too, that if some of you are being that forward thinking with this, like, we're definitely there and ready to have that conversation with you too.
Awesome. And thanks, Dan, for that input. I think one of the other kind of categories of questions that I'm seeing here is okay, so as we're managing this, as we're going through this process, as we're looking at these solutions and trying to leverage them as best we can, right, to get the most value out of all of the solutions, you know, how do we handle some of the changes that are happening? You know, events are generated and things like that. You know, how do we stop that kind of stuff? And from a Dragos perspective, again, we're passively monitoring that network. We're not actively scanning the devices or doing anything like that. And we're also not proactively stopping anything. Now, that comes into a different set of integrations that we offer from a network security side, in things like firewalls and other types of technology, you know, software-defined networking solutions that are out there. But again, we are not prohibiting those changes because that can be such a risky endeavor to try to go down as, hey, let me stop people from making those changes when maybe there's a little bit of a process upset and we need to have operators doing the things in real time to try to control that process before it becomes a very critical situation. And so again, I think from that side, we're not stopping it, but again, we're cataloging all of those things, and we can accept those new levels of communication. We can accept that new firmware version as the new baseline, as the new, you know, documented version or the new documented set of communications that should be out there. But we're definitely not stopping it from happening and things like that. So John or Dan, any thoughts from you guys on that stuff?
Yeah, I mean, that's just the nature of the manufacturing and industries like this. You know, the availability is always number one. And so, you know, any kind of proactive prevention is really tricky. It would need to be highly customized, and so then it often isn't cost effective. That's not saying, you know, I'm excited. You know, I think there's a lot of research to be done in that area and a lot of areas to go forward with that. So, you know, this certainly isn't the end. You know, let's not say forever we're never going to do that, but right now we're just, you know, we need to maintain availability. So back to you, Josh.
Sounds great. All right, we've got just a couple more minutes left with this. And some of the questions are around, you know, how does this apply to IIoT, industrial Internet of Things? And I think what we're starting to see is a plethora of devices and communications coming from even smaller and smaller devices, right? Not at your typical network switch or a workstation, right? We're seeing sensors that are now doing the, you know, communications, or they're doing it wirelessly out in a, you know, on a pipeline, or they're doing it out in a tank farm, or they might be in a factory, you know, that's got a lot of, you know, spread out disparity. And so you're seeing, you know, either public infrastructure, or you're seeing different things like that. And so how can we apply these different types of things to IIoT networks? Dan, I'll let you start from a kind of a, how does Pi handle IIoT, or what's the message there? And then I'll finish it up.
Yeah, totally. And I'll try to keep it short this time. The short and simple answer is, first, it doesn't have to be a custom development experience. Usually what that is saying, okay, we want to extend this amazing cybersecurity approach to this new area of our organization, this new IoT device network. Okay, this is the kind of devices, this is the make and model, the vendor, or this is the industrial protocol. One of the questions was about SNMP, for instance. Yeah, like, this is the industrial protocol that's used for communication back and forth between these two. All right, on the AVEVA side, since you all are helping to contribute the data infrastructure, what off-the-shelf tools do you have for clicking into that particular transport or that machine language? And usually it's that straightforward. So I'm saying, excellent, we'll do Redfish, IPMI, SNMP, DNP3, like just matching the off-the-shelf like driver, if you will, with those IoT platforms. So the short answer is it generally tends to be not as difficult as folks would think to extend this to completely new sources. And then from there, it's like, great, all those scenarios that we just talked about today just extend to a whole new set of information out there. And especially for folks out there who say, okay, well, what if we do have to do some custom coding or development? Well, that's one of the values of using a data infrastructure that's designed for critical operations, and that's not IT-centric. It doesn't require you to have massive expertise in computer programming. It's like, no, if you do have to do some custom coding, the APIs and SDKs that we make available are designed for use in critical operations, for making those common tasks of getting data, relaying it, buffering it, encrypting it, making those straightforward. So short and simple, like simply getting that data into the infrastructure tends to be fairly straightforward. And then I'll leave it for you to talk about, okay, like, what does it look like once we have it in as well?
Absolutely. And I think that's one of the biggest things is hey, so where do I architect, right? John and team kind of put together this sample network architecture diagram that we referred to multiple times throughout the different scenarios. And really what it comes down to is, where are you going to place those sensors, and where are you going to place those data archive collection points, right? Because you can have multiple collection points where information is being captured, and then you can create either an independent network, which you might call a security network or a management network, and then all of that network communication, again, outside the OT, outside of the IIoT infrastructure is being used for that management, security, and response capabilities. One of the things that they also talked about, one of the other questions kind of related to this, was this idea of should we do asset management, separate in IT versus OT? And I don't want to say, for your business without knowing your business, whether you should do that or not. I think a couple of things to consider though is, can the solutions that are built specifically for OT, like the Dragos platform, can those solutions integrate with my IT tools? That's one of the things that we often get is IT saying, hey, we have compliance, we have regulation. I saw a question in here about, how does this apply to the European data protection regulation, right? How do we ensure that the data that's being collected is staying within the confines of our country, and we know how it's being used, and we can delete it when we need to? I think a lot of that plays a very critical role in how you're going to architect these solutions, who will have access to these solutions. And because you deploy some of these solutions in your environment, you get a lot more visibility into how things are communicating. Our OT teams, our services teams constantly share stories internally about different things. And one of the scenarios was, hey, we were out at, customer X. They don't dispel that, but, we were out at a customer and finding out that all of these different remote access connections were coming into the environment. Nothing was breaking, nothing was shutting down, nothing was stopping, nothing was changing as a result of it, but they just didn't know. And so when you think about that, how can my IT and OT teams work together to satisfy the mission of compliance, regulation, ensuring that what my OEM vendor, what my system integrator, what my management company has told me they're doing is in fact actually what they're doing. I think that provides some really good stuff. So we've got just a minute left. I think we need to wrap things up now, but again,
Can I throw in one thing, Josh? Just
go ahead,
quick.
John.
So at the NCCoE, we are always looking for the next project. What use cases are people looking to see? So if you're interested in that IIoT use case, please reach out to us, and we'd be happy to look into doing that next time. Back to you, Josh.
No, that's great.
Quick, Josh, real quick, and to tag along with what John's discussing. We're going to be releasing, hopefully within the next 2 months, the Federal Register notice looking for participants and they're responding to and recovering from cyber attack. We would love to have you join. One of the biggest things is your product has to be available to the public. It cannot be in progress. It has to be available to the public, and we look forward to your participation. Sorry about that, Josh.
No, that's good. That's good. I want to make sure that, you guys get your plugs in, because I think that's really important. We have had such great experiences working with you guys. Really appreciate it. And again, all about supporting the community. Now, you know, we kind of focused in 1810 on how do we identify, protect, detect, you know, and now we're going to finish it up with this next version with recovering and responding, right? How do we do that? So looking forward to the results of what comes out of that project next. So again, thank you all so much for joining us today. There was one question about how do you get in touch with us? The easiest way, I think, is really just going to be reach out, sales@dragos.com. Tell them, hey, I'm interested in talking, you know, in the email, reference the email thread or the subject line, webinar, OT webinar, manufacturing webinar, whatever you want to reference, sales@dragos.com. Tell them I'd like to talk to John, Josh, Dan about this, and we'll correspond with you directly. We'll get you in contact. I promise not to have the salespeople hassle you, and then we'll take it from there. But once again, thank you all so much for everything. Really appreciated the time today. Hope you found it eventful and helpful. Looking forward to talking with you again soon. Take care, everybody.